Good morning. In previous lecture, we discussed general form of Newton-Raphson method. Today, we will apply the same concept for load flow, that is Newton-Raphson method of load flow. Consider a power system having n number of buses. First bus is slack bus and remaining buses, bus number 2 to n are PQ buses. First assume PQ buses, then later on we will include PV buses also. Recall the apparent power SI injected at ith bus of the power system is given by Pi plus J Qi. This can further be written as Vi II star. We have discussed it. This can further be written as Vi k equal to 1 to n Yik Vk star Vi star, or take conjugate of this Si star can be written as Pi minus Jqi is equal to Vi star II is equal to Vi star summation k equal to 1 to n Yik Vk. During formation of Y bus, we have seen it in detail. We have seen II can be written as Yik Vk for all the buses. So, here we want to write Pi and Qi separately, that is active and reactive power injected at ith bus. So, Pi can be written as real part of this. Earlier we have denoted Vi, that is voltage at ith bus, is equal to magnitude times delta I, phase angle. Similarly, for Vk we can write magnitude of voltage at kth bus and delta k phase angle. Yik is the element of Y bus corresponding to ith row and kth column. So, this phasor Yik can be written as magnitude Yik and phase angle denoted by theta Ik. Substitute these values in this equation. So, Si star can be written as Si star is equal to Pi minus J Qi will be equal to Vi star. Vi is Vi delta I. So, Vi star can be written as Vi minus delta I. Vi minus, because of conjugate delta I outside, summation k equal to 1 to n, where n is number of buses, Yik Vk. For Yik we can substitute this Yik angle theta Ik times Vk angle delta k. This can further be written as Vi, take magnitudes together, k equal to 1 to n, Yik, this magnitude, then this magnitude, Vk, angle take together theta Ik plus delta k minus delta I. Okay. So this is nothing but Pi minus jqi. So separately the active power injected at ith bus can be written as real part of this, that is Vi k equal to 1 to n Yik Vk cosine of this angle theta ik plus delta k minus delta I, and reactive power injected at ith bus, or better right here we can rub this. Reactive power injected at ith bus can be written as Vi summation k equal to 1 to n Yik Vk sine of theta ik plus delta k minus delta I. Please note here we have written Si star Pi minus jqi. So here we are writing qi, so put negative sign here. These two equations are very important and will be frequently used during load flow solutions. So mark these equations as equation A, and for qi equation B. Please note it. Fine. So we can say that from bus number 1 till bus number n, bus number 1 is slack bus. So remaining buses, bus number 2 to bus number n are PQ buses. We have assumed, initially we have assumed that all buses from 2 to n are PQ buses. Later we will include PV buses also. So I ranging from 2 to n, Pi, suppose for bus number 7 you want to find the P7. So P7 can be substituting I is equal to 7, you can get P as well as Q7 also. So for all the buses we can calculate P and Q, because for PQ buses P and Q are specified. Should I rub this? Okay. Let us introduce two functions, one corresponding to P, one corresponding to Q, to apply Newton-Raphson method for load flow. So say Fi is equal to del Pi. Del Pi is difference of a specified power at ith bus and calculated power at ith bus. Pi calculated, or you can say Pi. Pi is a function of V and delta. Theta and Yik are constant quantities. These are the part of Y bus. So once Y bus is formulated, these quantities are not going to be changed. Only the variables will be V or delta. So we can say from here that Pi is a function of delta and V, we can say it. Similarly, Qi, the reactive power injected at ith bus, is a function of delta and V. For our case, we have assumed that from bus number 2 to bus number n, all buses are PQ buses. Corresponding to this, we will get delta and V, that is delta 2, delta 3, delta up to delta n. Similarly, V2, V3 up to Vn. So we can say that Pi is a function of delta 2, we can write here directly, delta 2, delta 3, delta n, and V also, V2, V3 up to Vn. If we have obtained our solutions, that is the value of unknowns. For PQ buses, unknowns are delta and V. So our task is to calculate the values of delta and V. So once we have calculated delta and V corresponding to those delta and V values, that is delta 2, delta 3, delta n, V2, V3, Vn, we can calculate Pi at any bus from 2 to n, and that calculated value of Pi should be ideally equal to the specified value of Pis, that is a specified quantity P and Q we are having for PQ buses. Similarly, say some other function Gi is given by delta Qi. The another specified quantity for PQ buses is Q. So, delta Qi again we can write difference of a specified quantity Qis is for a specified quantity minus calculated value of Qi. Qi is function of delta and V, and we have assumed our buses from 2 to n are PQ buses. So, delta 2, delta 3 up to delta n, V2, V3, Vn. So, we have introduced two values. Recall from Newton-Raphson method discussed in the previous turn. On that turn, we discussed that the quantities, if we denote capital F R, check your notebook, can be written as minus j times R minus 1, this matrix, times del x R minus 1. Just check it. Here our functions are Fi and Gi, where I is any bus. So, for ith PQ bus, we have assumed all the buses except select bus are PQ buses. So, ith PQ bus right here. For ith PQ bus, we can write this Fi Gi for ith. Directly we can write del Pi del Qi. This Fi Gi, that is del Pi del Qi, is equal to minus Jacobian matrix. See your notebook. On previous turn, we have derived relation for the elements of Jacobian matrix. So, what are these relations? 1 and 2 here, del delta del V, see your notebook. So, from there we can write del Pi upon del, first variable is delta 2, next will be del Pi, the next variable delta 3, del delta 3, and so on up to del Pi upon del delta n. We are having n minus 1 delta values. So, start again V2, next will be del Pi upon del V2, then next V3 del Pi upon del V3, so on del Pi upon del Vn. For all the variables, we have taken partial derivative. This constitutes the first row of this Jacobian matrix. Write the second row. So, next is del Qi. Again the variables are same. So, here we can write del Qi upon del delta 2, same variables, del Qi upon del delta 3 del del qi upon del delta n del del qi upon del V2 del del qi upon del V3 dot 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 so on del del qi upon del Vn times right here variables. So, corrections will be del delta 2, this will not be sufficient. So, write here del delta 2, del delta 3, del delta n, del V2, del V3, del Vn. We will write the order also. So, order of this is 2 by 1, order of this will be 2 by, see the quantities from 2 to n minus 1, again from here 2 to n minus 1. So, we can write the order of this Jacobian matrix 2 cross 2 times n minus 1, the order of this Jacobian matrix. What is the order of this? The order of this will be again how many rows? Here we can write 2 into the same here n minus 1 by 1. Clear? So, we have assumed our total number of PQ buses are n minus 1 from bus number 2 to bus number n. We have written these relations for ith PQ bus. So, now we will write for all the PQ buses bus number 2 to n. So, directly write this del P and del Q. Is equal to, let us denote the elements of Jacobian matrix J11, J12, J21, J22 times del delta for this and del V for this, del delta del V, where del P we will write here, or I will rub this, where del P will be this del P. We have taken buses 2 onwards till n. So, first one will be del P2, then next del P3 and the last del Pn. So, order of this will be starting from 2 to n, that is n minus 1 cross 1. Next we will write del Q. Del Q will be equal to again del Q2, del Q3 and the last term del Q n. Then let us write del delta. Del delta will be again this side quantity unknown quantities are there, these quantities are known, these quantities are specified. So, for PQ buses delta and V are unknown. So, for all the buses del delta will be written as del delta 2, del delta 3 up to del delta n. And del V can be written as del V2 del V3 up to del Vn. Order of this is again n minus 1 cross 1, same order, n minus 1 cross 1, same order, n minus 1 cross 1. Next task will be to get the values of elements of Jacobian matrix J11, J12. I am rubbing this. So, J11 can be written as, let us number it 1, 2, here also 1, 2. So, J11 means 1 from this side, 1 from this side. First one from this side, left side, and second one from the right side. Similarly, J12 means first one from left side P, second one from right side V. So, first write J11 first from both sides. So, that is nothing but del P upon del delta, first from this side. And we know P is also from P2, P3, del P2, del P3 like that. Fine. So, J11 will be equal to del P upon del delta. One more thing. Before this, we have written for ith PQ bus del Pi del Qi. Observe there, minus sign is there. So, we can write del, first element is del delta Pi upon del delta 2. So, in general, del delta Pi upon del delta j, suppose, can be written as what is del Pi? Del upon del delta j, and this is difference of specified and calculated, that is Pi specified minus Pi function of delta V. Fine. So, that can be written as, this is a specified constant quantity independent of delta j, so 0. So, this can be written as minus del Pi upon del delta j. So, this minus sign cancels the minus sign there. So, now we can write J11. Similarly, for Qi also del delta Qi upon del delta j can be written as minus of del Qi upon del delta j. Other two terms can also be written in similar manner, that is del del Qi upon del say Vj will be equal to minus del Qi upon del Vj, and the fourth one corresponding to J12 del delta Pi upon del Vj can be written as minus del Pi upon del Vj. Just you can remove del sign from here and minus sign from here. So, you know it. Let us proceed for J11. So, J11 is del P upon del delta, and the dimension of del P you know from 2 to n. So, that can be written as, no negative sign now here. So, directly we can write del P2 upon del delta 2, del P2 upon del delta 3, del P n upon del delta n corresponding to all delta. Now next, del P2 upon del V2, then del P2 upon del V3 up to del P2 upon del Vn. This completes the first row of, okay, we are writing J11 only, so we will stop here because this will come under J12. So second row of J11, del P3 upon del delta 2, this del P3 upon del delta 3, del P3, this was P2 upon del delta n, check it, and so on. The last row will be corresponding to Pn. Corresponding to P2 we have written first row, corresponding to P3 we have written second row, and corresponding to Pn we will write n minus 1th row, that is del Pn upon del delta 2, del Pn upon del delta 3, del Pn upon del delta n. Now write J12, we will write here itself. Should I rub this? So J12 again we have numbered 1, 2 and from right side 1 and 2. So J12, first one belongs to the left hand side del P and the second one belongs to the right hand side del V. That is, here we will write J12, first one P and second one here it will be V. Right, we have del V here from del V2, V3, Vn. So write the first row del P2 upon del V2, del P2, del V3, del P2 upon del Vn, first row. Second row del P3, del V2, del P3, del V3, del P3, del Vn. The last row del Pn upon del V2, del Pn, del V3, del Pn upon del Vn. The order of this will be, what is the order of this? N minus 1, and this one is n minus 1, starting from 2 to n, here also P2, P3. So order will be n minus 1 cross n minus 1. Similarly, the order of J11 was n minus 1 cross n minus 1. Now next we will write J21. So corresponding to J21, again Q, so write here Q, 1 delta, this will be delta. Q also starts from bus number 2 to bus number n, and delta also from delta 2 to delta n. We have rubbed this, you have noted down. So write it, del Q2 upon del delta 2, del Q2, del delta 3, del Q2 upon del delta n. The second row del Q3, del delta 2, del Q3, del delta 3, del Q3 upon del delta n. The last row del Qn upon del delta 2, del Qn upon del delta 3, del Qn upon del delta n. Fine. Again the order will be n minus 1 cross n minus 1. The last one we will write here J22. The J22 will be which matrix? 2 2. Second from here, second from here, del Q upon del V. Del Q upon del V. See the dimension of Q and V, n minus 1, Q2, Q3, Qn. Similarly for V, V2, V3 up to Vn. So we will write here del Q2 upon del V2, Q2, V2, same Q2 upon del V3 and so on, del Q2 up to del Vn. This completes the first row. Second row, del Q3 upon del V2, del Q3, del V3, del Q3 upon del Vn. The last row corresponding to Qn, del Qn, del V2, del Qn, del V3, del Qn upon del Vn. Again the order will be starting from 2 3 n minus 1 here and 2 3 n minus 1. The order of this matrix J22 will be n minus 1 cross n minus 1.